Bismillahirrahmanirrahim. Today, I'd like to review some of the material that we have talked about before and add to it, refining some of the knowledge that we have had. I've done two figures here for you. Let's look at these individually. The first one here has this particular line. I've labeled it line L. As you recall, you can also name lines using some points on the line. So let's label some of these. Let's call this one A. Let's call this one point B. There's a point right here. Let's call that point C. So this line, line L, can also be referred to as, for example, line AB, with that particular symbol representing the line. You can alternatively label it as line CB and BC, etc. As you can see, there's more stuff here going on. I have a right angle over here, and I know that because there's a symbol over here. Thus, the red little symbol suggesting that that is a right angle, meaning that it's a 90-degree angle. Well, there's a ray over here. Let's label that. It's a ABC. Let's call that D. And for the completeness sake, let's put a point over here. Let's call this one E. And for another reference, let's call this point over here point F over here, so we can talk about it. So now there's a lot here, right? Now you agree that we have a ray over here, ray CB, correct? This ray, in fact, is right here, goes over here, and goes in this direction over here, correct? So this is a ray CB. If I were to kind of take out the ray and draw it individually, you'd be saying, okay, this is a ray like this. So this is C, and that's B. So you can say that's a ray because it's sitting on top of a line, but that's okay. We're okay with that. An equal opportunity ray, so to speak, right? So, okay, so we have a ray CB. And you would also agree that there's a ray over here and CA, correct? It's going in the opposite direction like this. And in fact, ray CB and ray CA, these are called opposite rays. If they're going in opposite direction, like 180 degrees, so to speak, they're called opposite rays. Okay, very good. And now you notice, of course, that this 90-degree angle, if you were to name it, so how would we name that 90-degree angle? Well, we could call it angle DCB, because we have to include the vertex here. We can't call it angle C because there are several angles, right, that use the same vertex, that's point C. But tracing this angle DCB would be one way to name the angle. Also, FCB would be another perfectly alright name, or BCF. These are all different names for the same angle. So we can say that the measure of this angle, the measure of angle DCB, is 90 degrees. If you recall, that's how we say measure. When we want to talk about what's the measure of the angle, how many degrees that is, we use that little m to denote that we're talking about the measure of the angle. And if you recall, these two angles here, angle 1 and 2 that I have labeled over there, now those two angles, when you add them up together, they add to 90 degrees, right? Because they're like in the tummy of the 90-degree angle, so to speak. So then we say angle 1 and angle 2 are, you remember, are complementary. Very good. Complementary angles. Like that. So they're complementary. They're complementary angles. So if two angles add up to 90 degrees, they are called complementary angles. So angle 1 and angle 2 are complementary. Now I want to suggest to you, complementary angles, they don't have to be sitting next to each other. For example, I could have an angle over here, like this, and let's say this is 60 degrees, and I can have another angle like this, all right, and that's 30 degrees. Now if you take 60 degrees and add it to 30 degrees, they add up to 90 degrees, right? So you can call this one, for example, angle M, and this is angle N. You can name these angles by their vertices because there is only one angle there from each vertex, right? So now these are two angles. They're separate. They're not sitting next to each other, but they add up to 90 degrees. So they too are complementary. So you can say angle M and angle N are complementary. So complementary angles, they don't have to be adjacent, but they can be. So angle 1 and angle 2 are complementary adjacent angles. Now this is a term that you must remember. Adjacent means two angles that are sitting next to each other. I'll define that for you in just a second, a bit more precisely. Adjacent complementary angles, and these are not adjacent, they're not sitting next to each other, but they still add up to 90 degrees, right? So they are complementary. So M and N are complementary because they add to 90 degrees. And so 1 and 2 are also complementary because they add up to 90 degrees. But 1 and 2 are a little bit more special because they're like neighbors. So angles that are neighbors are called adjacent angles. So adjacent angles are, if you want to say, neighbor angles. Okay? Now, what does that really mean? Neighbor doesn't sound like a very geometric term, right? Well, that's true. So how can we define adjacent angles? Well, adjacent angles are those angles that basically they share a side. So here I have two angles over here. Okay, here's angle 1 and angle 2. A different angle 1 and different angle 2. You agree that here's angle 1 and here's angle 2, correct? Okay, so those are two angles. Now, if you recall, every angle has a vertex like this, and it has one side and has another side. So it has two sides and a vertex, and one side, two sides, and a vertex. Okay, so all angles have two sides and they have a vertex. Now, what two adjacent angles? Okay, angle 1, for example, there's one side and there's the other side. Okay, and then angle 2 is one side and there's the other side. So both of those angles have two sides and a vertex. They share a vertex, of course, like this. But adjacent angle, or neighbor angle, so to speak, they have one side that they share, and that's why they're called neighbors. It's like the two apartment buildings next to each other. They have the same wall. They're like neighbors, right? So adjacent angles, they share a side. Okay, so two angles are adjacent angles if they share a side. Okay, that's, you can say that's more of an official definition of adjacent angles. So you can have complementary angles that are adjacent, they're neighbors, and you can have complementary angles that are not adjacent. Okay, so that I wanted to suggest to you over here. Now here we have another drawing that I have made for you. Let's see what's going on in this drawing. Here we have a line, and I have not given this line a name with the lowercase letter. So, okay, so we can name this line. Let's call this line AK, right? Of course, you probably thought I was going to say line AB, but that would be correct also. So we have a line AB, okay? And then we have a segment here, don't we? It's not a line. CD here, it's not a line. So it's a segment CD, and you write that like this, correct? So that's a symbol for a line, and that's a symbol for a segment. Okay, so we have a segment CD, and we have a line that's AB. Now here we have some angles that created also. So, and I have suggested here by these symbols over here that those two angles are congruent, correct? If you want to denote two angles to be congruent, that is, if you want to suggest that two angles are congruent, you use the same tick marks, use the same symbols inside of them in their bellies to suggest that they are congruent. Now I use those particular symbols. I could have used any one of very different types of symbols. I could have used one tick mark, or I could have used like one tick mark but like this to make sure everybody's clear about it, or I could have used two tick marks like this, right? So you can use various symbols to denote that two angles are congruent. So I chose that to make sure that everybody sees, hey, those two angles are congruent. And we have a name for those angles, which we learned last time. These were vertical angles, right? So these were vertical angles right there. So those are vertical angles that are congruent. So angle AKC, so angle AKC, okay? Now these two, we said this one and this one, and we're given that they're congruent, correct? So angle AKC is congruent to angle BKD, because that's what we're given. Those are vertical angles and they are congruent. Now, that's pretty cool. So we got that. Now there are more angles here as a review. Now this angle, let's label some of this. Let's call this one 1, let's call this 2, and 3, and 4. Okay, so we know angle 4 and 2 are congruent. We can write that too. Angle 2 is congruent to angle 4. Okay, we got that. So now we say angle 1 and angle 2, they are supplementary, aren't they? They're right next to each other. They add up to 180 degrees. So we can say angle 1 and angle 2 are supplementary. So that's another term that we learned last time. Supplementary. Supplementary angles are those angles that add up to 180 degrees. You must also appreciate now that these two angles, they're supplementary, angle 1 and 2, are also special because they are also adjacent angles. So they're not just ordinary supplementary, they are adjacent supplementary, because by this analogy you can imagine you can have two angles that are supplementary but they are not adjacent. Well, let's draw them out. So here's an angle. Okay, here it is. I'm going to say it's 120 degrees, and I'm going to draw another angle over here that's not connected to it, okay, and that's 60 degrees. That's 120 degrees I meant to say, and that's 60 degrees, and these two add up to 180 degrees. So these are two supplementary angles here that are not adjacent. Okay, they are not adjacent. So adjacent angles are those that share a side, right? You can have adjacent supplementary angles that are neighbor supplementary angles, so to speak, and non-adjacent supplementary angles. Definition of supplementary angles are any angles that are that add up to 180 degrees. In fact, let's call this angle A. Let's call this angle B. I could draw another angle over here, okay, and that's also 60 degrees, and then let's call this angle M here, for example. Now I can say angle A and B are supplementary, and I can also say angle A and angle M are supplementary, correct? They also add up to 180 degrees. And you can also see that A and angle B and M are congruent, correct? So you can have multiple angles you're talking about in a particular diagram that are supplementary, multiple complementary as well. So again, there are two types of complementary. There are adjacent complementary angles and adjacent supplementary angles as well. Now you can have angles that, of course, that are neither supplementary or complementary, but they're still adjacent. So here it is. All right, so I'm going to draw this out. All right, so this angle is 30 degrees, and this angle here is 20 degrees. Now they add up to 50 degrees. There's nothing special about 50 degrees, right? It's not 90 degrees. So they're not complementary, they're not supplementary, but they are adjacent because they're neighbors, right? So these are adjacent angles. So, well, that's cool. Good for them. So you can have adjacent angles that are not, they don't have to be necessarily complementary or supplementary. Okay, I just wanted to go back to this particular picture here and point out one more thing to you. And I'm going to say that K is the midpoint. K is the midpoint of CD, segment CD. That means that CK and KD are of equal length. Okay, I can represent that by writing a little tick mark over here like this, and now everybody knows that CK and KD are congruent. So if K is the midpoint of CD, that means a midpoint, if you recall, is a point that divides the segment into two congruent segments. If K is the midpoint of CD, this implies that CK is congruent to DK, like this, or KD, you can say that. So CK is congruent to DK. Another way of saying this is CK, the measure of CK, is equal to KD, like this. Their measure is the same. If you recall, if you don't put anything on top of those letters, then that means the measure of the segment CK equals to. And we're talking about the measure of a segment, we say they're equal to. And we want to say when two segments are congruent, you put the little bar on the top. So you read this as CK is congruent, the segment CK is congruent to segment DK, and you read this as CK, the measure of CK equals, or the length of CK equals the length of KD. So we learned about midpoints like this. There's one more thing I wanted to talk about before we introduce to you some new concepts today, and that is as follows. I have a line over here, okay? and on this line I have some points. Okay, let's call this point E, let's call this point F, and let's call this G, and I have a point over here, and let's call that point R. Okay, now I say over here that points E, F, and G, points E, F, and G are collinear, C-O-L-L-I-N-E-A-R, collinear. That this term means that they are on the same line. Okay, so points E, F, and G are collinear. Okay, now points E, F, and R are not collinear because R is not on the same line. Now you have to understand any 2 points will be collinear. I have this point over this point. I could just draw a line between connecting those 2 points. Right here it is. Here, well, that's not quite right, but here it is. Let me try this again. Whoa, there we go. So if you had any 2 points will be collinear, that just give any 2 points, okay, they're collinear. Any 2 points, they're collinear. But the concept of collinear only applies to like more than 2 points, okay? So because you have to have 3 points to figure out if they're all together or not. You follow what I'm saying? Because any 2 points will be collinear. Well, R and F will be collinear if I were to draw a line that goes through them like this, right? Here's a line that goes through both of them, so they're collinear. But when we talk about being collinear, we at least have to talk about 3 points, because any 2 points will be collinear because you can always draw a line between 2 points. In fact, that's one of the great maxims of geometry, so to speak, and we say it like this: 2 points, this you must remember, 2 points determine a line. Now this is actually more profound than you might think of here, this particular statement. So 2 points determine a line. It is, if you give any 2 points, there's only one line that will go through them, right? There's no 2 lines that go through these two. See, so if you have E and R, there's only one line that goes through them, and that's this one over here. Try to draw another line that goes through both of them. Can you? Let me know. No. So 2 points determine line. So as long as you have 2 points, you determine line. Okay. So when we talk about collinear points, it means that lines are all, or those points are all on the same line. And we say R, E, and F, those 3 points, they are not collinear because they are not on the same line. In the same way, R, F, and G are not collinear. Okay? All right. So, but if I were to draw another line like this, for example, here it is. Let me draw this line. I'll draw it in red. It's supposed to be one line. Okay? And I put another point over here. I put K. Then I can say K, R, and F are collinear because they are on the same line. Okay, so this was a bit of a review and a little bit of addition to some of the stuff that you already know. Now I'd like to introduce you to a little bit more new concept. Okay, what I have drawn here, it's not a parallelogram. It's not meant to be a parallelogram. What this is called is a plane. So this is a plane. It's like a sheet of paper. In geometry, a plane is like an imaginary surface. It's a surface, imaginary surface, so to speak, a two-dimensional surface, but that goes in infinite directions. So it goes on forever in all directions like this. So it's kind of hard to draw an infinitely long paper, right? So we kind of draw it like a, like a paper, like you see, like a parallelogram, but you're kind of looking at it from the top. See, so you draw it like this, but it's understood that it is a plane. It's an imaginary surface that goes on forever in all directions. So this is called a plane. Okay, so now so far, for example, we talked about a point. A point, if you remember, are labeled with capital letters. They don't have any particular dimension to it, right? There's no length and width. And then we talked about like lines, okay, like this. Lines are named with some points in it, and lines go on forever, but they don't have like dimension. They don't have width. They don't have any width, and you can't really measure them their length because they go on forever. Now a segment, so you can measure a segment like this to see how long it is, but there's no width to a segment. It doesn't have any width this way. So in the same way, a plane, it goes on forever, right? And so you really can't measure it in that way, okay? And it does not have any thickness in this way. So it's like no thickness, so to speak. So these are like imaginary concepts that help us understand a real life situation. Well, you say, well, why are we imagining these things that you can't really have, right? How can you have a plane that has no thickness, right? Well, of course you can't have that per se, but what you learn from geometry, of course, you can apply to real life examples, right? If you use triangles to calculate the height of a mountain, for example, things like that. So there's, of course, real life application for all of these concepts, and they're useful. But when we think about this, and we have to be precise in how we define this, but we define a plane by saying it's like a surface, like a paper that goes on forever, okay? And of course, there are millions of points on this plane, so I can just draw out like 3 points that are like on the plane, okay? So in fact, we can name a plane using 3 points that are on the plane. So let's call this point A, point B, and point C. So one way to name a plane is just to call it using any 3 points that are on the plane. So here's plane A, B, C. Now you don't put anything on the surface, you just call it plane ABC. Well, why don't you use 2 points? Well, I'll show you why that doesn't work. So you have to use actually 3 points to name a plane. You can use any 3 points. Let's say if I have a point over here, let's call it point L. I could call this plane plane, P-L-A-N-E, and A-L-C. Now, so that's cool. So you can name a point. So to name a plane, you have to use 3 points that are on the plane. Not just any 3 points, okay? I'm going to tell you that in just a second. So why that is. There's another thing that you can do. You can name a plane using capital letters. Let's call this, for example, K. So you can call this simply plane K. So you have a plane K. Now mind you, K is not a point that's on the plane. There's no point right there or something that's named K or something like that. K is just an alphabet you chose to represent the plane. In fact, if there is a point A over here, you can't call this plane like plane A because this causes confusion because there's a point over there, right? So you use different alphabet that's not like not one of the points. So K here does not represent a point, it's just the alphabet, and you use capital letters to represent a plane. So alright, so we have a plane here. So a plane is the two-dimensional figure that goes on forever in all directions like this, right? And there are infinite points over there, and you use 3 points to name a plane, or you can use a capital letter also to name a plane. Okay? Now, planes can be a little bit tricky to draw, so here I'm going to show you how I typically do it. And so you kind of draw like a parallelogram over here, and because it's supposed to be like a 3-dimensional picture. Now what I'm going to do is I'm going to draw another plane that's kind of cutting through it, okay? So it's like this, okay? That. All right. This is supposed to be like this. Kind of messed it up, but you can see it can be tricky, right? Okay, so I happen to have a handy eraser, so let me erase this. Okay, now, so there are 2 planes over here. So I'm going to make this dotted line, because what's happening here is that these 2 planes are intersecting, and I'm going to suggest this. I'm going to put that as a dotted line because that's behind this blue plane. Okay, so that's behind this blue plane, and this part is behind the other plane like this. So if you use this dotted line, now what you see over here are 2 planes intersecting each other. There are 2 planes that are intersecting each other. I have this plane over here, the blue plane, right? Here's the blue plane, right? And it's like a piece of paper that's going through another piece of paper, okay? You see that? So and then they intersect, and where the planes intersect I hope you appreciate the intersection of two planes is a line. Just like if you were to take two papers and if one were to cut through the other, where they cut through would be like a line. Okay, and that's very important. So let's label some of these things so we can talk about it. Let's call this plane plane K because we already did that in the other picture, and maybe we can even use the same color, for the sake of consistency. Well, it's not the same color. So here's plane K. So let's label this plane plane P. That's easy enough. So to call this one plane P. Now, you understand what the intersection of the planes is a line. So, well, maybe we can just draw out that line. So I'm going to draw out this particular line over here. So I'm trying to draw it out. So here's a line. So the two planes intersect in this particular line. Let's call that line L. Well, we like to give you some points over here. So let's label this point A. Then let's call this point B. So that's point A. That's point B. And I'm going to put another point over here, collinear, okay? So that means that right here on the same line, okay, that's C. C is on the same line. And let's put some more points over here. Here's point D, okay? And then I'm going to put a point here on plane P, and I'm going to call that A, B, C, D, let's call that E. That's point E. So here, I'm going to write it out so there's no confusion. I'm going to say points A, B, C, and D are on, watch this, they're on A, B, C, D, they're on plane K, okay? And then I'm going to say, so there's no confusion, I'm going to say there's no confusion, I'm going to say points, watch, A, B, C, and E, A, B, C, and E are, there's an and here, and E are on plane P, aren't they? Because see, this line is the intersection of two planes. So A, B, and C and E are part of plane E, and points A, B, C, and D are part of plane K. Does that make sense? I hope that makes sense to you. Now, listen carefully. So I can name planes, I said, using 3 points, and I can name planes using a capital letter. Here I have labeled named this plane K using a capital letter, and this plane P using a capital letter P. Now, K and P are not points that are on the plane, okay? There's no point K hidden there, point P hidden there. They're just names to name the plane. The intersection of two planes is a line, as you can see over here. All right. Now, I said to you over here, you can use any 3 points to name a plane. And I said, you can't just use any 3 points, okay? Because, for example, what I must say is this. So you can use any 3 points, any 3. So you can use any 3 blank points on the plane, any 3 non-collinear. So you can use 3 points, but you have to make sure that they are not collinear. They can't be on the same line because A, B, and C are part of plane P, and A, B, and C are also part of plane K. So you have to make sure that the three points that you use to name a plane, they are not part of this they are not on the same line. So you can use 3 alphabets, 3 capital letters, 3 points to name a plane, as long as those 3 points are not collinear. They're not part of the same line. They can't be lined up because there are many planes that go through over here. In fact, there are infinite number of planes that go through here. Just imagine a book over here with all the pages going like this. Can you imagine? All these pages. So all these there are a bunch of planes that go through this, that can go through the same line, right? So there are infinite number of planes that can actually intersect through the same line over here. Okay, so 3 points. So 3 points that are on the same plane, 3 points that are on the same plane, they're called coplanar. Or any points that are on the same plane. Don't have to be 3. There are 2 points in the plane. They're called coplanar if they are on the same plane. So 2 points or any points are coplanar if they are on the same plane. Just like any points are collinear if they are on the same line. Okay? Inshallah, next time we will elaborate on this. We'll try to put together everything that we have learned so far and go from there. Until then, as-salatu wa-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.